So again, 312 is equivalent expression or representations of trig functions. 315 is our last unit for AP, so we're getting warm, okay? We're going to stop after today. Tomorrow we'll review 310, 311, 312, and then you're going to take a quiz on that stuff. So where the notes end today is where that quiz content will end. A quick refresher of the things you have to know. So we need to know all of these identities, like the blue box. You need to know all of the reciprocal identities, Pythagorean identities, even odds, and cofunction identities. And then we added on to these the sum and difference, with the exception of the tangent, right? We said tangent, sum and difference is not in the content you need to know for your AP exam. What's the pattern for sine? Good. Sine, cosine, cosine, sine. Same or change? Same. Good. Same sign. And then cosine is? Cosine, cosine, sine. Good. And change. Good. So we didn't do this example. This is example, I think it's 7, right? Is that the number right? I know I had 2 sets of notes. Okay, so this time it says find the exact value of the expression cosine 11 pi over 6 cosine pi over 3 plus sine 11 pi over 6 sine pi over 3. So we're working backwards, right? They already expanded it. So you have to identify what the pattern is, condense it down, do what you're supposed to do with those angles, either add them or subtract them, and then actually find the value there. So if it's cosine, cosine, sine, sine, which trig function has that sum formula? This would be cosine. And if it's cosine, do we keep or change the sign? Change. So if this is plus, then we're going to take that 11 pi over 6 and we're going to subtract from it pi over 3. And then we keep going. So I want to find a like denominator here. I would multiply by 2 and 2. I'd get 11 pi over 6 minus 2 pi over 6, which is 9 pi over 6. Not a unit circle angle, but simplifiable, right? 9 over 6 becomes what? 3 pi over 2, and we are finding the cosine of that angle. What's the cosine at 3 pi over 2? Good. So this time it was expanded out. We got to work backwards. You're going to identify whichever of the trig functions it is, sine or cosine. From there, you'll know if you keep the sign or you change the sign. Physically add the 2 angles or subtract the 2 angles. And then it should be a unit circle angle. And then you'll find that exact value. If it's not a unit circle angle, then the answer would have stayed in that format. Like it could have said cosine of 5 pi over 7, for example, and you would have left it alone.
Why don't you take the equation and solve it the way the other ones?
Well, you can, but it's easier to do it the other way, I think. I mean, you can. It's the same. It would be the same. Yeah. I just think it's easier. It will also say which of the following is the equivalent. Oh. And so that you would want to know this format. Does that make sense? Mm-hmm. Yeah. So it could ask you both. It could ask you to find the exact value, which takes it all the way to the 0, which you could get either way. Or it could say which of the following is the equivalent expression, and that one you would do that. It also could give you, like, not angles there. It could give you variables. So you could see, like, if it was theta and beta, this would be the cosine of theta minus beta, and it would be left like that. All right, now we get into the double angle formulas. Again, we can ignore tangent. Tangent, I don't know why they don't like tangent, but they don't. Okay. Tangent is not on, the tangent double angle is not on your AP exam, but your sine and cosine are. So this is used as replacement. You will physically see something that says sine of 2u, and you can replace it with what it equals, which is 2 sine cosine. When you see cosine 2u, you have 3 options. You can replace it with any one of those 3. Cosine squared minus sine squared, 2 cosine minus 1, or cosine, 2 cosine squared, sorry, minus 1, or 1 minus 2 sine squared. Now, if you don't remember these formulas, ideally you memorize them because you need them. But if you don't memorize them, then I'm going to show you how you can derive them from your sum and difference. So sine of 2u would be the same thing as saying sine of u plus u, right? Because u plus u is 2u, right? You with me? Yeah? So then let's say I chose to express it as a sum. I would use my sum and difference formula for sine, which is sine, cosine, cosine, sine. Sine of u, cosine of u, plus cosine of u, sine of u. And they are both the same term, so we can combine them together. 2 sine u, cosine u. The order is different, but in multiplication that doesn't matter. So that gets you this one. So if you forget, then you can derive it by finding the sine of an angle plus itself, because that would be what sine of 2u is. And then if you were to forget the cosine one, now I would say, okay, this would be cosine u plus u, or x plus x. The variable doesn't matter, okay? What's the pattern if I extend out the cosine? The sum of the cosine becomes? What's the pattern for sum of cosine? Cosine, cosine, sine, sine, change the sign. So this would be cosine u minus sine u, sine u. And this would be cosine squared u minus sine squared u. That's where that one comes from. So again, ideally you memorize it, but if you don't memorize it or you get stuck or you question yourself, you can expand it and then use your sum and difference formulas. Now, how would I get from this guy to this one? Good. Sine squared plus cosine squared equals 1, right? So if I want to replace sine squared, it would be sine squared would equal 1 minus cosine squared. So if cosine 2u minus 1 minus cosine squared becomes cosine squared u minus 1 plus cosine squared u, which is 2 cosine squared u minus 1. That's the second one. And then take this same one that we started with, cosine squared u minus sine squared u. How could I make it just in terms of sine? Good. So take the same thing. Cosine would be 1 minus sine. So 1 minus sine squared u minus sine squared u would equal 1 minus 2 sine squared u. So ideally you memorize it because obviously it's a lot less work. But should you get hung up, you can always derive one from the other, okay? So I know for me, like these two specifically, I know one is 2 cosine minus 1, and I know one is 1 minus 2 sine squared. And to remember which, God bless you, which one is which, think C comes before S. So the cosine is the one that comes first, and the sine is the one that comes second. I don't know if that helps you. That helps me. And then I know cosine squared minus sine squared is not, it would not be sine squared plus cosine squared because that would equal 1. That's wrong. So it's cosine minus sine. In those cases, cosine comes first. I will post the Quizlet that has all of these formulas, including the trig identities and all that stuff. I'll put it on the module right where it's at, like the quiz review is. I'll put it right there because now it goes to this. It goes to all the double angles. Yeah, yeah. Good? Okay, so now here's how we can apply it. You don't need to know tan of 2u, and you don't need to know sum and difference of tan. Yep. All right, so example 8 says find all the solutions of the equation on the interval of 0 to 2 pi. So these will be built into your solving equations one. If you look at A, notice it says sine of 2x. Now this is where people get super confused because if it just said sine of 2x equals 0, then I would solve it like the multiple angle one. I would find where sine is 0, which is at 0 and at pi, plus 2n pi, plus 2n pi. And then I would divide everything by 2. And I'd get 0 plus n pi and pi over 2 plus n pi. That's if there's only one. So if there's only one trig function with a double angle, which double, obviously 2, but anytime there's a multiple angle, that could have been 3x, that could have been x over 2, that could have been x over 3. That's from section 310. Those are called multiple angle ones. You can also solve it using your double angle formulas, but this guy you cannot solve using your multiple angles. Like I can't add sine of x to the other side. I'm stuck. There's nowhere to go. So if there is a double angle mixed with anything else, you have to use the double angle formulas. So what did we say sine of 2u is? If you need a cheat, you can go back to the last slide. What is sine of 2u? 2 sine u cosine u minus sine of x. Well, and actually it wouldn't be u. It would be x. Sorry. Let's make the variables the same. Sine of x cosine of x minus sine of x equals 0. Then what would you do? You can, but you can't divide by sine x because you'll lose it. So rather than do that, I would say factor it out. Take out your sine x, and I'd get 2 cosine x minus 1 equals 0. And now I split and solve. Yep. Because you're dividing both, by factoring it out, you're dividing both of these by sine. So the signs like cancel out. Does that make sense? You mean on this guy? Yeah. So it's not sine squared. It's 2 times sine cosine. If it was sine squared, there'd be 2 sines. Does that make sense? Okay. All right, now I'm going to split and solve. So I get sine of x equals 0, and I get cosine of x equals 1/2. And it gave you the interval, which means I'm not adding on the interval. Like I'm not adding these on because it gave me the interval. So where is sine 0? 0 and pi. Where is cosine 1/2? Good. 5 pi over, well, it's pi over 3 and 5 pi over 3. If it didn't give you no interval given, then my answer is 0 plus 2n pi, pi plus 2n pi, pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. And if it's multiple choice, the 0 is not there. It looks like that.
Wait, what do you mean if given the interval?
So I gave you the interval. I said here, right? This one says restrict it. So if it says 0 to 2 pi, your answers should only fall between 0 and 2 pi. That's it. Just give those answers. You're done.
Oh, that's why you don't add plus 2.
Correct. Correct. But if the instructions don't say on the interval, you have to add on the interval. Questions on that one? All right, so now example 9 says find all the solutions of the equation of the interval 0 to 2 pi. So again, it gives you the interval. Now A has a combination of cosine 2u and sine. Like I hope at that point you don't try to do double angle. I mean a multiple angle because there's 2 trig functions, right? We can't solve like that. So what can I replace, because there's 3 options, what can I replace cosine of 2u with? What's the first one? Cosine squared minus sine squared. If I put that in here, I still have 2 trig functions, yes? And I can't solve it. So I don't want to use that one. What's the next one? 2 cosine squared, it would be x minus 1. So if I replace that, 2 cosine squared x minus 1 plus sine x, what's wrong? Still have 2 trig functions. So my last option is, and so if I do that one, I only have sine, and I can work with it. So that's why you need to know all 3, because one might be what you need over the others. Okay, so now what? It's like having an x squared and an x. What are you going to have to do? Factor it. So one option, I'm going to show you both ways. If the signs throw you off, not positive, negative signs, but the word sign, then use a replacement. So I could literally say A equals sine of x. We do this in Algebra 2 Honors, right? We substitute it in. So then I would get 1 minus 2a squared plus a equals 0. I would want to, 1, put it in order, 2, eliminate the leading negative because I don't like a leading term to be negative. That's just personal preference. So if I reorder it, it looks like this. And if I want to get rid of the negative, I can multiply everything by -1. And now I'm there. And now I got to factor. And there's like 300 different ways to factor this. 1, I could do trial and error. It's not so bad because they're prime numbers. 1, I could do the multiply the first times the last. And then the other thing that I don't even understand, but my children do it, is like the kickback, like you kick the 2 back. I don't know. That's like a whole new, if you don't know what I'm talking about, pretend it didn't exist. Okay. I would say typically we teach first and last, where you multiply first times last. You find the factors of that sum to the middle term. You replace the middle term. You factor by grouping. Or you do trial and error. So factors of 2a squared would be 2a and a. And then factors of -1 that sum to -a when I do the outer and the inner would be -1 and +1. If factoring with a leading term gets you need to spend some time on that. Like, you don't want to take an AP exam and then not be able to get to an answer because you can't factor. And if that means reviewing factoring, do it. Okay? There's nothing wrong with that. Sometimes people have a gap there, especially COVID children. Yeah. All right, so now I'm going to split this and set it equal to 0. And I would get a equals -1/2 and a equals 1. But it's not a, it's really what? Sine. So sine of x equals -1/2 and sine of x equals 1. And then where is sine? -1/2. First of all, it's negative, right? So we're talking bottom. 7 pi over 6, and let's see, other over 6 in the bottom, 11 pi over 6. And then where would sine be 1? At the top. Good. Pi over 2. So if the SIN signs throw you off, then substitute in the A. If you can function without it, then literally just factor. So this, when I factor and multiply by a -1, it becomes 2 sine squared x minus sine x minus 1. And then when you factor, instead of having an x on that term, you have a sine. It's the same thing. So you don't have to do the A substitution. But if that throws you off, like if you can't work with words instead of letters as you factor, then do it, okay? All right, questions on that one? All right, so look at the difference between A and B. What do you spot? It's an inequality, and man, does it change the process. It is such a pain in the butt, so take a deep breath. Okay, so first of all, the equation itself would end up being the same. I would put 1 minus sine squared x plus sine of x, except that it is greater than 0. I would reorder it, multiply by a -1. So all of this we just did, which is why I'm kind of hurrying through it, because what happens after this is what gets complicated. Then I would have factored it. 2 sine x, -1, +1. And when you get an inequality with a quadratic or something that has 2 terms, which is technically what this is, we usually do a test point. If you remember this, we get our zeros, we put them on a number line, we plug in points from those ranges, right? Does this sound familiar? The good news is that the process is similar. We have to set it equal to 0 to find those zeros, except we're not on a number line anymore. We're on a circle. So I'm going to solve this. I'm going to set it equal to 0. Instead of it being greater than, I'm going to set it equal to 0. And I would get that sine of x would equal -1/2. Sine of x would equal +1. Same answers as before, which are 7 pi over 6, 11 pi over 6, and pi over 2. So the solving up to this point is exactly the same. We would move them, we would factor them, we would solve them. Because we want to know where it's 0. You with me so far? Yes or no? Yeah. Okay, now picture your unit circle. Where is pi over 2 is at the top? 7 pi over 6 is here. And 11 pi over 6 is here. Those values give it a 0. So if I plugged in those values, my answer is 0. Okay? Which 1 means because it says greater than 0, not equal to, I can't include any of those answers. Those answers would all have parentheses. Does that make sense? Because it's not or equal to. Now, the ranges you have to pick from are from here to here, from here to here, and from here to here. And I'm going to pick, like I do on a number line, one value in each of those spots. I'm going to plug it in, and I'm going to see what gives me a true statement. So pick a value. Actually, I can come all the way here. Pick a value from that first range. So between 11 pi over 6 and pi over 2, what's the easiest thing to plug in? 0. So let's plug in 0. We're plugging it into the original statement. So cosine of 2x plus sine of x is greater than 1 is what we're going to test it out in. So cosine of 2 times 0 plus sine of 0 is greater than 0. And I get cosine of 0. What's cosine of 0? Mm-mm. 0 being the angle, so the angle is 0. What's the x at 0? 1. Yes? This is 0. This angle is 0. The coordinate point there is 1, 0. Yes? I need 24. Yes, I understand that the cosine at 0 is 1s. Okay. What's the sine at 0? 0. Is 1 plus 0 greater than 0? Yes, we're getting better. Good job. Okay? Which means this section of my curve is going to work. I get to keep it as an answer. You with me so far? Now I go to the next section. I'm going to pick an angle from that second little piece of my circle. What's the easiest thing to pick from there? Pi. So let's plug in pi. 2, oh no, not 2, sorry. Cosine of 2 times pi plus sine of pi is greater than 0. What's the cosine at 2 pi? 1. Good, that was faster. 1. What's the sine at pi? 0. Is 1 greater than 0? Yes, which means I also get to keep this part. So this part's good, this part's good. Now go to the bottom. Pick an angle from that bottom section. What's the easiest one? 3 pi over 2. So I'm going to do cosine at 2 times 3 pi over 2 plus the sine at 3 pi over 2 has to be greater than 0. So the 2's cancel here and I get cosine at 3 pi. Where's 3 pi? Where pi is, right? On the left. All the odds would be on the left. What's the cosine there? -1. Good. What's the sine at 3 pi over 2? -1. -1 plus -1 is? -2. Is -2 greater than 0? No. So this part of my graph I cannot keep. No, it is not. Okay. All right, you with me so far? Because now we know our ranges, now we got to name them. It's a good question. So we can either do an interval notation or we can do an inequality. But think about how they have to get chunked up, okay? First of all, this section, this top right section of my graph was technically from 11 pi over 6 up to pi over 2. But is that a range you can list? Can you say 11 pi over 6 to pi over 2? No, right? Because 11 pi over 6, first of all, is bigger than pi over 2. I can say pi over 2 to 11 pi over 6, but I can't say 11 pi over 6 to pi over 2. So I have to give it in 2 parts. I have to do 11 pi over 6 to 2 pi, and I have to do 0 to pi over 2. So that one section has to get cut into 2 parts. No, because it says from 0 to 2 pi. If you didn't say that, yes. So I don't know if anybody heard her, but can you just say negative 11 pi over, negative pi over 6? If it had given me an open interval, yes. But because it says my answers can literally only be from 0 to 2 pi, I have to name these in parts that would be from 0 to 2 pi. So this first section is from 0 to pi over 2. It can't include either of them because, oh no, the 0 can. Sorry, the 0 gets a bracket. It can include 0 because this has a bracket and because 0 was not one of my initial key points that gave the answer to be 0. Pi over 2 was. If I plug in pi over 2, I get 0. My statement that I'm looking for is greater than 0, not greater than or equal to. So I can't include pi over 2. Now the next range is from pi over 2 to 7 pi over 6. So I would say pi over 2 to 7 pi over 6. 7 pi over 6 cannot get a bracket because 7 pi over 6 gives me an answer that is 0 and it is not or equal to 0. And then the last little sliver was 11 pi over 6 to 2 pi. It can't include 11 pi over 6 because that would give me 0. And it can't include 2 pi because the original interval gave a parentheses on the 2 pi. This is obviously the most complicated question you could get. Like one stupid inequality sign changes that whole thing by a lot. I did not put this on Thursday's quiz. I am not promising you won't see it on your test though. Okay? You need to understand that it is from the range. So it's like we take that line and we test points, but we're doing it from our unit circle angles instead of a line. Questions on anything we talked about today? Okay.